Okay. So to walk through what to do with this here, you recorded in this top table, you recorded your grams. Is that right? Everybody confirm that this is grams up here? And you did your molar mass calculation. Your answer should be, what is it, 100.09 or something like that, right? And then your compound for your chalk is calcium carbonate. All right. So now what we're going to do here is we're going to jump down here. We're going to convert our masses to moles. All right. This should be reviewed. This is what we just did on our test recently here. So just to clarify that, you should be taking your number of grams and then multiplying it by a factor. You want grams on the bottom and 1 mole on the top. And this is where the 100.09 goes. And this is your number. That should not be, there you go. Okay. So that is how you do both of those calculations. So you'll get some number there for this one and some number there for this one by doing that with both of your numbers. So far, so good? Shake your head yes or no. So far, so good? All right. Now what we're going to do is we're going to talk about this thing called a BCA chart, the before, change, and after chart. The purpose of a BCA chart is to talk about how something changes. So what we'll be doing shortly with these is we'll be using them to show chemical reactions and how chemical reactions and amounts of things change. But for today, we're just going to use it to talk about the chalk. All right? Y'all with me here? If you're not listening here carefully, you need to be, because this is very important. This is the foundation for what we'll do for the rest of our short school year here. So the single most important thing here, what is the only unit, meaning unit of measure, that can go in the BCA chart? The answer is moles. Okay? Moles only in a BCA chart. There is never an exception to that rule. The reason is that when we do chemical reactions, chemicals react with each other by counting atoms, right? One atom of this combines with one atom of that to make whatever compound, right? So moles is our way of counting particles. And so that's why only moles can go in the BCA chart. Always and forever. There will never be an exception to that. Sound good? Cool? Everybody turn to your neighbor and pinky promise them that you'll never write grams or anything else in a BCA table. Okay? So now what I want you to do is I want you to fill in your BCA table by writing these things. But you got to think really carefully here. The beautiful thing about a BCA table is that it tells a story of what happened. So think about it for a second. Tell this story what happened with your chalk. First, you weighed your chalk and you converted it to moles, right? Then what did you do with your chalk? Drew something, wrote something, whatever, right? Then what did you do with your chalk at the end? Weighed it again, right? So you have a mass and we have a number of moles from the beginning, which is the before, and you have a mass at the end, right? A moles at the end, right, Yoo-hoo? So what goes in the before is the initial from step 1, the moles from step 1. And what goes in the after? The moles from the step 2 down here, right? And then in order to find the change, you get to do the step 3 part. So you do your best to figure it out, because I think it's simple and I think you can. And I'm going to work it out quietly up here. So if you need to check your answer or if you get stuck, you can look up. I'm just going to have to make up numbers here. Okay, so I've got mine all done. So when you're done, you can look up and check your answers up here. I just kind of had to make up some numbers on mine. So my numbers are just sort of made up numbers. Just to have a blank piece of paper, you can just turn it over and do this on the back. Okay. Let's pick a quick chemical reaction. How about, let's pick a pretty easy one. How about this? Can you balance that? Write that on your paper and balance it. You've got more chlorine over here, so you've got to add some chlorine over there. All right. So to balance this one, you have to do a 2 here and a 2 there. All right. Now, we're going to actually turn this into a BCA table. Are you ready? All right. Here you go. B, C, A. Now we're going to tell the story of this reaction. Are you ready? Or am I going too fast? So let's suppose that we're going to do this reaction. So we go and we gather all of our materials and we end up, we get a little bit of a sample of some lithium and we get a sample of some chlorine gas. And then we're going to react them together to make some lithium chloride. Sound good? Sound good? All right. So let me just give you a really big challenge here. How much, let's say we start out with 2 moles of lithium, just to make it a really easy number, okay? How much chlorine gas do you think we should start out with? Anybody want to take a wild guess at that? 4, 10? Sure, let's start with 10. I'm pretty sure we'll have enough that way. And then, how much lithium chloride will we start out with?
6.
Are you sure?
16.
Think about it, guys. What are we doing here? No. When you're baking cookies, how many cookies do you start out with? No, cookies.
12.
You get your flour, you get your sugar, you get your butter. How many cookies do you start out with? 0. Unless you make cookies before you ran out of cookies. You don't have any cookies. Does that make sense? Shake your head yes or no. Does that make sense? You don't want to start out with any of your product because you didn't make any yet.
So you're talking like this is like before we even have the
B, 4, right? This is before. That's why I said this is telling a story, right? All right, are you ready for the next thing? How much of our lithium should we use up? Should we just react it all away? Yeah? I'll give you a hint. It's easier if we just react it all away. Should we just do that?
Yeah.
Okay, let's just react it all away. So that means we're going to use up 2 moles. Sound good? That was easy, right?
Yeah.
Now, here's the challenge part. Are you ready for it? If you're not paying attention right now, you need to put away your other thing and pay attention. This is the single most important part right here. How do we figure out how much chlorine of this we're going to actually use? Because I'm going to tell you right now, you got way more than you need here. You ready? We started out with 2 moles of lithium, okay? We're going to do a little conversion to figure out how many moles of chlorine gas we need. Are you ready? So what you have to do is you have to look at the balanced chemical reaction here. okay? And we're going to make a little factor here to help us figure this out. So you just take the numbers that are here. What number is this right here? It's a 1. You can't see it, but it's a 1. So we're going to do this. I'm going to put the lithium number on the bottom. Do you see how I just put that there? Nothing fancy. I just took that and put it there. And then this one here, I'm going to put on the top. Oops. Do you see that? You can hold on to it, and these notes will be online. You can finish them up.
Okay. Thank you.
Okay? And now watch this. It's kind of silly doing it this way. I'm going to multiply. I'm going to put that 2 in there, just because we always start with what's here in the front. I'm going to multiply times everything that's in the top, which is kind of silly, but I just did it anyway. And then I'm going to divide by everything that's in the bottom. And my answer is, do you see here that my lithium's canceled out and my moles was still left? Right? And my chlorine was still left. I should have put a 2 right here. Do you realize that that's what just happened there? So, how many moles of chlorine gas am I actually going to use? Say it out loud, everybody. 1 mole. All right. And now here's the next question. How much of my lithium chloride am I going to be able to produce? Anybody want to take a wild guess? Well, can we do the same thing here? Oops. Do you see what I just did there? I just took these numbers right here and put them here just like that. Do you see that? Does that make sense? I bet you know what the answer is now without doing any calculator, right? 2, right? Because 2 times 2 divided by 2 equals 2. Right? So now, am I going to add this or subtract this right here? Add. Good. You guys are smart. Now, can you figure out the A row? How much you're going to have after? 2 minus 2 equals 0 moles. We used all of it up. 10 minus 1 is 9 moles. That's not how you spell mole. And 0 plus 2 is? There you go. That was pretty easy, right? There you have it.